The total cost difference between a vehicle with an internal combustion engine and an electric vehicle. To approach this research question, the overall cost of each vehicle needed to be calculated. The total costs have been defined by the cost to operate, the cost to purchase, and the cost to maintain each vehicle. The sum of the three will be the total cost of each type of vehicle. At the end of the research, it was found that over 10 years, the total cost of a vehicle with an internal combustion engine is $34,830 and $52,087 for an electric vehicle, making ICE vehicles more cost efficient. I arrived at my current research question at the end of my junior year. I began the semester researching computers and electricity when I found an article about EVs and decided that I wanted to pursue this topic. I chose this question because my family works in the auto industry, and I have been interested in cars my whole life. On top of that, background research on climate change led me to dig deeper in the world of EVs. During my research, I realized that electric vehicles were rapidly becoming more popular in the environmental protection scene, and many people were inquiring about potential financial burden. This question aims to provide an answer to what the true cost difference is between an EV and an ICE vehicle, or if such a disparity even exists. A study by the University of Michigan was used to calculate the operating cost of an EV and an ICE vehicle. According to the University of Michigan's Transportation Research Institute, the national average for operating an EV is $485, whereas the national average for operating a gas-powered vehicle is $1,117. In terms of maintenance costs for an ICE vehicle, the costs can be quite expensive. Since vehicles with an ICE have many rotating parts that are susceptible to damage and replacement, costs can add up over time. On top of that, changing fluids in an ICE can be very expensive, whereas EVs do not need nearly as many fluid changes. According to Your Mechanic, a company that provides mobile car repair and maintenance services to car owners, the three most expensive models to maintain over 10 years are the Chrysler Sebring, BMW 228i, and Nissan Murano. The three car models that are least expensive to maintain over 10 years are the Toyota Prius, Kia Soul, and Toyota Camry. Additionally, oil changes and other routine maintenance add even more to the maintenance cost. Electric vehicles do not have rotating parts and require far less maintenance. The most significant maintenance cost that an EV might have is its battery. This will be used to calculate the total maintenance cost. Due to the complexity of an electric vehicle's battery, this cost can be particularly expensive. According to Green Car Reports, the cost to replace the battery of a 2017 Chevy Bolt is $15,734 and $5,500 for a 2011 to 2014 Nissan Leaf. However, in the rare case that a battery becomes defective, many manufacturers offer battery warranties that will cover this cost. A battery warranty will last 8 years and 100,000 miles or 10 years and 150,000 miles, depending on the state. Using previously mentioned data from Your Mechanic and Green Car Reports, averaging the most and least expensive cost to maintain each type of vehicle will result in an estimation of the total maintenance cost. This maintenance cost will be assumed to cover 10 years for purposes of comparison with gasoline vehicles. It is important to note that EV batteries will likely last far longer than the warranty, and that the $10,617 cost is just an estimation of what a car owner should be prepared to pay as a maintenance expense. When it comes to purchasing electric and gas vehicles, it is important to consider size, age, and features when choosing two cars to compare. Additionally, prices will vary with brand, quality, and location of purchase. With this in mind, the MSRP of the 2016 Chevrolet Spark and 2019 Chevrolet Bolt have been chosen to represent the capital cost of gasoline and electric vehicles. The Spark runs on gasoline, and the Bolt runs on electricity. The Chevrolet Spark's capital cost is $12,660, and the Chevrolet Bolt's capital cost is $36,620. Therefore, $12,660 will serve as the gasoline vehicle capital cost, and $36,620 will serve as the electric vehicle capital cost. With that said, direct competitors for the Bolt will still be cheaper despite features included in the Bolt that are not in the Spark. For example, a competitor to the Bolt, the 2020 Civic Hatchback, has an MSRP of $21,750. This is still $14,870 cheaper than the Bolt. Even though these costs may not be typical or average prices for all cars over different fuel types, they will be used to compare similarly aged and sized vehicles, making them useful data points. As the University of Michigan study found, the average annual cost for operating a gas-powered vehicle was $1,117 and $485 for an electric vehicle. Even though these costs are averages and may not reflect the true value to operate the Spark and Bolt, their purpose is to serve as comparisons across different fuel types. The maintenance cost for an electric vehicle is $10,617 and $11,000 for a gasoline vehicle. Finally, the capital cost for a gasoline vehicle is $12,660 and $36,620 for an electric vehicle. In this table are the final results of the research. After the numbers had been added up, it was found that ICE vehicles cost $34,830 over 10 years, and electric vehicles cost $52,087 over the same period of time. However, EVs will potentially cost a few $100s less to maintain over 10 years. The cost to purchase an EV is significantly higher than an ICE vehicle. In this case, EVs were 2.89 times more expensive to purchase. However, this may not be the case for all electric vehicles among brands other than Chevrolet. Due to the fact that all cars are very different across different models and brands, it is difficult to choose an electric vehicle and a traditional vehicle that are similar. The Bolt and the Spark have some different features, but are similar in age, size, and are of the same brand. On top of these reasons, these vehicles were chosen because of their availability and potential to experiment. In addition to the research in the ARP project, an experiment with the Chevrolet Bolt and Chevrolet Spark was conducted to see if the research backs up what happens in the real world. To achieve this goal, the cost of operating and maintaining each vehicle was calculated. According to the University of Michigan's Transportation Research Institute, the average price of regular gasoline on December 23, 2017 was $2.441 per gallon, and the average price of residential electricity in the United States in October of 2017 was $0.1284 per kilowatt hour. At the 6-month period of driving the Bolt, the mileage came to be 7,000 miles at 3 miles per kilowatt hour. Dividing 7,000 miles by 3 miles per kilowatt hour and multiplying the quotient by $0.1284 per kilowatt hour results in $299.6 over 6 months and $599.2 over 1 year. Since the Bolt did not have any maintenance, the cost was $0. The total cost to operate and maintain the Bolt over 1 year was $599.2. The cost to operate the Spark for 6 months can be calculated using the same distance that the Bolt drove, divided by the fuel economy of the vehicle, multiplied by $2.441 a gallon. The fuel economy of the Spark is 3.89 miles per gallon. The cost to operate the Spark is $439.25 over 6 months and $878.5 over 1 year. The Spark had one oil change in the 6-month period that it was driven, which cost $60. The total cost to drive the Bolt over 1 year is $599.2 a year and $938.5 a year for the Spark. Over 1 year, the Spark will be $339.3 more expensive to operate and maintain. Contrary to the experiment, the research found that it costs $2,217 to maintain and operate the Spark over 1 year and $1,546 to maintain and operate the Bolt over 1 year. This means that it would be 1.43 times more expensive to operate and maintain the Spark over 1 year. However, this experiment found that it is actually 1.57 times more expensive to operate and maintain. Therefore, such a small difference between the numbers means that the research is accurate. It is likely that the cost of electric vehicles will decrease in the coming years. Along with the ever-expanding market for EVs, technological advancements will increase their range and reliability and cut their production costs. It is difficult to determine when EVs will be just as affordable as their counterparts, but this time is sure to come. At the end of the research and experimentation, it was found that gasoline vehicles are cheaper to purchase, but more expensive to operate and maintain. However, the difference in capital cost of each vehicle is too large to make EVs cheaper nowadays, therefore making ICE vehicles cost less than electric vehicles. In addition to the comparison of the Chevrolet Bolt and Spark, another experiment had been planned to test if the research supported what was happening in the real world. However, due to COVID-19 circumstances, the experiment could not be finished. A go-kart, which ran on a gasoline engine, would be driven around a track. The number of laps that the go-kart could drive on 1 gallon of gas would be calculated. Then the price of that gas would determine how expensive it was to operate the go-kart for that distance. After this data had been collected, the go-kart would be modified to run on an electric engine. Then the go-kart would drive around the track for the same distance, and the amount of energy used would be determined. The cost of this amount of energy would be calculated based on the average cost of electricity in Michigan. Had the experiment been completed, the comparison of the costs to operate would look something like this. Multiplying the price of the fuel by the amount of fuel used would result in the total cost of operation based on the fuel type. After the totals had been calculated, the prices would be compared and conclusions about whether or not the research was supported could be made.